Hi everyone, welcome to this video where we will learn about Amazon MQ. My name is Aishwarya Sood. I'm working as a software engineer and AWS trainer, and I am 3x AWS certified, also an AWS Academy accredited educator. You can connect with me on LinkedIn at this profile name, and you can also scan the QR code to quickly view my profile. So let's begin today's video and see what we are going to learn in today's video. So I'll begin with the introduction to message queues, and then we will see what are message brokers, and we will learn about Amazon MQ. Then we will see how it works, how is it different from Amazon SQS and Amazon SNS. Also the feature, that is network of brokers, that is available with Amazon MQ, and the few instance types that are available with Amazon MQ. And we will also see how to set this up on AWS console. So let's begin. Before we start discussing any message brokers or something else, let me tell you about message queues first. We have messages produced by various services, applications, users, and processes. Whenever there is a need to collect, process, or take action on a message, we can queue this data, that is we call messages, in a message queue. So what are exactly messages that here I am talking about? The messages are nothing but usually small and can be things like requests or replies or error messages, or maybe just plain information. To send a message, a component called a producer adds a message to the queue, and then the message is stored in the queue until the another component, that is the consumer, retrieves the message and does something with it. That means it will producer will add a message to the queue. In queue the message will be stored. Consumer will take out the message from the queue and will process it. So this is about message queues. Now let's discuss a little about message brokers. So message brokers are often used to manage communications between on-premises systems and cloud components, basically in the hybrid cloud environments. It's a software that will enable the applications, systems, and services to communicate with each other and exchange information. The message broker does this by translating the messages between formal messaging protocols, and this allows independent services to talk with one another directly, even if they were written in different languages or implemented on different platforms. So message brokers can validate, store, route, and deliver messages to the appropriate destinations. They serve as intermediaries between other applications, allowing the senders to issue messages without knowing where the receivers are, whether or not they are active, or how many of them are there. This facilitates the decoupling of processes and services within the systems, and this is also the asynchronous processing, about which I'll be telling you in a while. And in order to provide reliable message storage and guaranteed delivery, message brokers often rely on a substructure or component which is called a message queue, that I just told you, and it stores and orders the messages until the consuming applications can process them. And in a message queue, messages are stored in the exact order in which they were transmitted and remain in the queue until receipt is confirmed. So that also varies from the type of queue. Like in queues also we have standard queues, we have FIFO queues. That is quite a different concept. Then asynchronous messaging. It is the driver of message brokers. Since this is an asynchronous communication, this means both the entities, that are producer and consumer, do not need to be present together to perform a task. Producer will send the message which will be stored in the queue, and the consumer will pull the message from the queue and process it. Then the broker routes each message through one of the two types of destinations. That is first is one-to-one messaging, which in queue, where it awaits the delivery to a single customer. Okay, and then next is the topic in the publish subscribe messaging, in which we create a topic where a message will be sent to a topic, and the message will be immediately sent to the subscribers of that topic. So let me tell you a little more about these two types of messaging. So the first one here is one-to-one model. This is a distribution pattern that is utilized with message queues with the one-to-one relationship between the message sender and the receiver. Producer will send the message which will be stored in the queue, and the consumer will pull the message from the queue and process it. Messages are stored on the queue until they are processed and deleted. Each message is to be processed only once by a single consumer. And once the consumer processes a message, the consumer has to explicitly delete it also, since it will not be automatically deleted from the queue. Message queues can hence be used as a great solution to decouple heavyweight processing. And many producers and many consumers can use a queue, but each message needs to be processed only once by a single consumer. For this reason, this messaging pattern is often known as one-to-one communication. And the next type that we have here is publisher subscribe model. So here in the message distribution of publish subscribe model or pub sub pattern or publisher subscriber model, whatever you want to say, you can call that. The producer of each message publishes it to a topic, and multiple message consumers subscribe to that topic from which they want to receive the messages. Publish subscribe messaging or the pub sub messaging is a form of asynchronous service to service communication which is commonly used in serverless and microservices architectures. In this model, a publisher sends a message to the topic, as I just told you, and on AWS this is implemented through a service known as Amazon SNS. It matches the topic to a list of subscribers who have subscribed to that topic and delivers a message to each of those subscribers, basically like the YouTube channels. So there will be, let's say this topic is nothing but a YouTube channel, and this publisher is nothing but the creator who is publishing the videos to this channel. So this creator is publishing the video to this channel, and all the subscribers of that channel will be getting the notification that the video has been uploaded. You can watch that. So this is a similar kind of thing here in the publish subscribe model. Now let's move to discuss what exactly is Amazon MQ. I would say it's a managed message broker service, message broker just we have learned, for Apache ActiveMQ and RabbitMQ that makes it easy to set up, migrate and operate message brokers on AWS cloud. But what's ActiveMQ and RabbitMQ? They both are the popular open source message brokers. Now what's a message broker? This is what we have learned in the previous slides just now. And Amazon MQ reduces your operational responsibilities by managing the provisioning, setup and maintenance of message brokers for you, and it manages the administration and maintenance of message brokers and automatically provisions the infrastructure for high availability, and there is no need to provision the hardware or install and maintain software, and Amazon MQ automatically will manage the tasks such as software upgrades, security updates, failure detection and also the recovery. It stores messages redundantly across multiple AZs within an AWS region and will continue to be available even if a component or even if a availability zone fails. Connecting your current applications to Amazon MQ is also easy because it uses industry standard APIs and protocols for messaging. This enables you to move from any message broker that uses the same standards to Amazon MQ by simply updating the endpoints of your applications to connect to Amazon MQ. You can see here also the producer is here, consumer is here, and the MQ broker is here as a middleware. Now let's dive a little deeper into the overview and the working, how exactly it works on the console. So as I told you earlier that message brokers will allow different software systems to communicate and exchange information, often using different programming languages and on different platforms. So with a few clicks in the Amazon MQ console, it provisions your broker with the support for version upgrades, so you can also use the latest version that Amazon MQ supports. And once you configure your broker, your applications can produce and consume the messages. Each Amazon MQ broker runs on a managed broker instance, which is the virtualized infrastructure that AWS provides when you provision a broker. You can choose from a range of broker instance types which we will be learning later in the session, and which are quite similar to how you select for AWS EC2 instance types, and which determines the infrastructure resources that are available to your broker and the hourly cost of operating the broker instance. So you would be thinking that, okay, I choose the instance type for EC2 also. Here also the instance thing is coming. What's exactly the difference? So the difference between EC2 instance and the broker instance is that your broker instance is fully managed and you can't SSH into it, whereas in EC2 the instance isn't fully managed and obviously we SSH into it to perform the further processing. And many organizations, particularly the big enterprises, rely on message brokers to connect and coordinate different systems. Message brokers enable distributed applications to communicate with each other, and they serve as a technological backbone for their IT environment. Applications depend on messaging to work. In many cases, these organizations have started to build new cloud native applications or to lift and shift applications to AWS. There are some applications that are too costly to migrate. In these cases, the on-premises applications must still interact with the cloud-based components. And Amazon MQ enables organizations to send messages between applications in the cloud and the applications that are on premises to enable the hybrid environments and application modernization. For example, you can invoke AWS Lambda from the queues and topics that are managed by MQ brokers to integrate the legacy systems with the serverless architectures. So here's a use case when we are using Amazon MQ for the hybrid environments. You can see this example shows that how you can use Amazon MQ to integrate both the on-premises and cloud environments by using the network of brokers feature of ActiveMQ, about which we will be learning in the coming slides. This diagram shows the message lifecycle from the on-prem producer to the on-prem broker, which traverses a hybrid connection between the on-premises broker and Amazon MQ. Finally, the message moves to the consumption within the cloud. Okay, the producer is residing on the on-premises, Amazon MQ, here it is on the cloud, which is a broker, and the consumer is cloud-based. So this kind of messaging between a hybrid environment, this is getting possible through the MQ, the broker that we are using here. So by now you would have got some idea about the message brokers and Amazon MQ. But the ones who would also know about Amazon SQS and SNS, you would be thinking that what's the difference, that when should I go for SQS or SNS and when should I go for MQ? So let's discuss a few differences between all of them, like between MQ and Amazon SQS and SNS, like when to use MQ and when to go for either SQS or SNS. So first, let me tell you about Amazon MQ. If you are using messaging within existing applications, or you want to move your messaging to the cloud quickly and easily, then Amazon MQ is recommended because it supports industry standard APIs and protocols, and migration can be done without rewriting the code of your application. It is a managed ActiveMQ and RabbitMQ service. This provides you with the fully managed ActiveMQ or RabbitMQ system in the cloud, with the support for a variety of industry standard and broadcast protocols like AQMP, JMS, etc. You can see the list here. It is useful when you have complicated delivery rules or when you are migrating an existing system from outside AWS into AWS and your systems happen to talk to one another with the standard queuing protocol. And here you pay by the hour, like pay per hour and the per GB that you are consuming. Also it can do the pub sub, and also the queuing is available there. But let's move to the SQS and SNS, when to go for SQS or SNS. So if you are building brand new applications in the cloud, SQS and SNS are recommended. They are fully managed and can scale almost infinitely with simple APIs. SQS and SNS can be used for decoupling, scaling, and to improve the reliability. SQS is a simple queuing service. It doesn't support many higher level abstractions like message routing, fan outs, distribution lists, etc. It's just a queue. a message is produced and a message is delivered at least once, and it is useful when you need a queue with limited backing logic. So you can use SQS and SNS to decouple and scale microservices, distributed systems and serverless applications and overall improve the reliability. The protocols that it supports, it's HTTPS, and you pay per request in SQS and SNS. It can't do the pub sub in SQS, but you can do pub sub obviously in SNS, because this is a publisher subscriber model that follows, and SQS follows the one-to-one messaging that we discussed earlier in this session. So the key takeaway from from all the differences, if you want to just remember the most important thing, it is for the application migration. It is for the applications which you have already on premises and you are thinking to move to the migration, or if you have producer on the on premises, the consumer is on the cloud, then MQ will be recommended. But if you have brand new applications that are like from scratch, you are building in the cloud itself, they are born in the cloud, for that applications SQS and SNS will be used. This is the main difference that you can remember. Okay, let's move to the basic elements that are there in MQ to make it work. Let's discuss all of them one by one. So the first element here we have is broker. It's a message broker. The message broker, it's just an environment running on Amazon MQ. It's the basic building block of Amazon MQ, and the combined description of the broker instance class, let's say M5 or T3, and size, which can be large, micro or something, is a broker instance type. For example, mq.m5.large. Okay, this forms a instance type. There are types of broker: the single instance broker and active or standby broker. So what's the difference? A single instance broker consists of one broker and one AZ. The broker communicates with your application and with an Amazon EBS or Amazon EFS storage volume. Okay, and active standby broker consists of two brokers and two different AZs which are configured in a redundant pair, and these brokers communicate synchronously with your application and with Amazon EFS. Next we have is configuration. So a configuration contains all the settings for your ActiveMQ broker, basically in XML format, and you can create a configuration before creating any brokers. You can then apply the configuration to one or more brokers, and to keep the track of the changes you make to your configuration, you can create configuration revisions also. Next we have is users and groups. So a user is a person or an application that can access the queues and the topics of ActiveMQ broker. You can configure the users to have specific permissions. For example, you can allow some users to access the ActiveMQ web console, and a group is just a semantic label. You can assign a group to a user and configure the permissions for groups to send to, receive from and administer the specific queues and topics. Next thing that we have here is storage. So Amazon MQ for ActiveMQ supports Amazon EFS and Amazon Elastic Block Store, that is EBS. By default, ActiveMQ uses the EFS for broker storage. To take advantage of high durability and replication across multiple AZs, you can use Amazon EFS, but to take advantage of low latency and high throughput, you can use Amazon EBS. But you can use Amazon EBS only with MQ.M5 broker instance type family. So that's just a simple thing you can remember. If you want to use EBS, there's just limitation on which instance type supports this. So let's discuss a little bit about the working of like how Amazon MQ works for ActiveMQ and the broker architecture. So we have learned about single instance broker and active standby brokers in the previous slide. Basically, a network of brokers is comprised of multiple simultaneously active single instance brokers or active standby brokers. Amazon MQ for ActiveMQ brokers can be created as single instance brokers or active standby brokers, and you can access your brokers by using any programming language that ActiveMQ supports, and can use a common protocols and messaging APIs. And you can configure network of brokers in a variety of topologies, for example concentrator, hub and spokes, tree or mesh, depending on your application's needs, such as high availability and scalability. For instance, a hub and spoke network of brokers can increase resiliency, preserving the messages if one broker is not reachable. Making changes to a configuration, revision, or an ActiveMQ, user does not apply the changes immediately. To apply your changes, you must wait for the next maintenance window or reboot the broker. You can see this diagram is illustrating the configuration life cycle, like if you make some changes to the configuration revision, how it will be applied. You make the changes are pending, and then you just have to decide when to apply the changes. Okay, you can have two options. First, the default one, the changes will be applied after next reboot. Okay, it is waiting. But if you do not want to wait, you want the changes to be applied immediately, you can configure that also. And that's how the configuration changes will be applied to the broker. Okay, and yeah, this configuration life cycle is done. Let's move to the next topic now, which is the network of brokers, which is another amazing feature that we get in the broker. So you can see in this figure to what we are doing here, to configure a network of brokers that spans AWS regions, deploy brokers in those regions, and configure the network connectors to the endpoints of those brokers. A network of brokers is established by connecting one broker to another using the network connectors. Once connected, these brokers provide message forwarding. For instance, if broker 1 establishes a network connector to broker 2, the messages on broker 1 are forwarded to broker 2 if there is a consumer on that broker for the queues or topic. And if the network connector is configured as a duplex, then messages are also forwarded from broker 2 to broker 1. Okay, you can see from broker 1 to 2 it was going, but if it is duplex, it will go from 2 to 1 also. Network connectors are configured in the broker configuration. So there are a variety of benefits in using a network of brokers, such as creating a network of brokers allow you to increase your aggregate throughput and maximize the producer and consumer connection count by adding the broker instances. You can ensure better availability by allowing your producers and consumers to be aware of multiple active broker instances. This allows them to reconnect to a new instance if the one they are currently connected to becomes unavailable. And because producers and consumers can reconnect to another node in the network of brokers immediately, and because there's no need to wait for standby broker instance to become promoted, client reconnection within a network of brokers is faster than for an active standby broker for high availability. So there are a few instance types that you will be getting as an option when you start creating a broker. To select for your broker instance, you can see a variety of instances and the description is given there. Like if we check the mq.t2.micro, it has one virtual CPU and 1 GB of memory, and the network performance is quite low. You can choose from all the instance types that are available. They differ from the resources that they have. Like somebody will be having 1 CPU, another is having 16 CPUs, 64 GB of memory, and obviously the network performance will be high as you go to the higher instance types. So let's now see how this exactly works in the AWS console. I'll just show you how you can set up the MQ broker on the AWS console for Apache ActiveMQ engine. So let's go to the AWS console and get started with the Amazon MQ. So here it is. First you need to go to Amazon MQ and then click on get started. So here we get the option for creating a broker. So for this demonstration, I'll be going ahead with the Apache ActiveMQ and click on next. Here you can select if you want a single instance broker or you want an active standby broker. Okay, so the differences we have already learned between both of them. I'll be going ahead for this demo with a single instance broker, and I'll go for Amazon EBS. Okay, so then we can select if we want a sample blueprint for a network of brokers, but no, for this demo I do not want. I am clicking on next. So here we have to scroll up and give a name to our broker. Let me give it as my my first broker will be fine. And broker instance type, you can select from here which one you want. So I'll go ahead with the default, that is mq.m5.large, and it will take around 20 minutes to deploy. Okay, and these are the settings that I have configured earlier. And then for the console access, what we have to do, we have to set a username and password. Okay, so let me set a username and password here. This username and password we have set because once we connect to our broker using the console, okay, we will get a URL. So it will ask the username and password to be entered. Okay, then if we want, we can configure some additional settings, but I won't be changing much here. Okay, but the security group I will be changing because by default it uses a default security group. But I'll use an existing security group, that is, I think, launch wizard 15. So I'll show you what are the rules that I have allowed in the security group so that you can get to know the differences why I am using this particular. There's just one rule that we have to add in the security group for the access by allowing port number 8162. That's why in this security group I have added that port already. That's why I'm selecting this security group. Okay, and other things I can leave as default and click on create broker. So now it will take around it is in creation in progress. It will take around 15 minutes to get this into the running state. So I'll wait for the status to be changed to the running state and then we will proceed further. So here it is, my broker is now in the running status. I waited for around 10 to 15 minutes and it came into the running state. So before we begin connecting to the broker, let me show you the security group that I used for this. This was the one, the launch wizard 15 that I used for my broker. So the main thing that you need to focus is this particular rule that you need to add. Okay, others are I just added them for some other purposes. They are not mandatory that you should add to your security group for your broker. No, that's not required, but this one you need. 8162 port should be opened in your security group whichever you are assigning to your broker. So make sure this rule you are adding, others are just optional. 8162 is required. So to connect to my broker, what I have to do, just go to this broker and you can see a lot of details are given here, which VPC it is using, which subnet it is using, what is the security group it is using, what is the configuration revision, that is the first auto generated one. If I want to create a new, that also I'll be able to do. Okay, and then what are the other configurations and how do we connect to this. So this is a URL that we need to use in order to connect to the broker from the console. You can see this is why I opened the 8162 port in the security group, because this is on this particular port. Okay, so I click on this URL and you can see this is the default page that I'll get. And to work on this broker, what I have to do, click on manage broker and then enter the username and password. And once you enter the username and password, just click on sign in and it will give you a page like this. Okay, so here you can manage your queues, the topics, subscribers, connections, any kind of thing. So basically what has happened in the entire session is that, just in short, I'll give you a brief thing that you can remember to understand why we are not using SQS and SNS here, why we went for message broker. So basically, as I told you earlier also, if you have the applications that you have built in the cloud itself, for them you can use SQS or SNS. But here we follow the broker for a hybrid environment. Okay, we can use if the broker, like if the producer was on the on premises and the consumer is here on the cloud, and all of the things, the queues, topics, that means what we do in SQS, what we do in SNS, we are managing through a central thing that here is the broker. Okay, so now the queues are not managed by a single thing, that is SQS. Topics are not managed by a single thing, that was SNS. Here we are managing the queues and topics for the hybrid communication from the broker. Okay, the broker that we just created. So if I go to queues, and I'll be getting multiple options to multiple operations that I can perform on the queue. I can create a queue. Okay, I can search for the queues that are already there, the number of messages that are pending, the number of consumers that are there, messages that are enqueued, that are dequeued, and any views, operations, whatever I want to do here. So let me create a queue, first queue. Yeah, this name should be fine. And then I click on create. Okay, so the queue will be created. Yes, it is ready. You can see I can create one more queue, second. Okay, now this queue has been created, and here if I click on my first queue, what I am getting, I can send some message. I can send the message from here. So I am getting all the options here. You can see. Okay, where I am sending the message to a queue. Okay, then all the other settings, where to reply to, what is the TTL setting, and number of repeats, what should be the delay in the message delivery, what is a message group, like all the settings that we have in SQS basically. So if you want to learn about SQS and SNS before this, you can watch another video that is for SQS and SNS, that is published on the same channel itself. So you can check out that also. Here you can enter the message body. Let me add something. Hi everyone. So this is the message body that I have added, and then click on send. So here I can see messages that are enqueued, the number of pending messages, it is showing 1. So if I click on this, and the message, if I open, let me see here. Yeah, here it is, the message has come. Okay, so if I open this message, I'll be able to see this, the message details and all the other details that were there. So this is how it is working. Similarly, I can create more queues, I can perform more operations, I can go for topics, I can create a topic here, I can add the subscribers, all the things that are possible with your queues and topics you can manage from a broker itself. Okay, the infrastructure is set up and you are just able to perform the operations here. So this was how you can create a broker and how you can set up all the broker thing on the AWS console for ActiveMQ. Okay, now let's get back to the slides, and just to wrap up the session, we will discuss how do we do the monitoring with the message brokers. So here, first point, Amazon MQ and Amazon CloudWatch are integrated. That means you will be using CloudWatch for monitoring your MQ brokers, and you can view and analyze metrics for your broker instances as well as your queues and topics. You can analyze and view the metrics from Amazon MQ console, CloudWatch console, command line, or even programmatically, and metrics are automatically collected and pushed to CloudWatch every minute. Okay, so this is how the monitoring will be working there on the brokers, and I hope you have understood all the basics and what we have learned in this video. So this is it for this video. We will meet in the next video. Thank you.